in this extra video for angles inside of a circle, we'll be talking about inscribed triangles and inscribed quadrilaterals. So what an inscribed triangle is, and basically you see two diagrams of them here. It's a triangle that is captured within your circle. So each angle of a inscribed triangle is an inscribed angle. And remember that the three angles of a triangle have to add up to 180 degrees, and the three arcs have to add up to 360 degrees, which makes sense because if our relationship with inscribed angles is that the angle is equal to arc divided by 2, all right, if I take up all the arcs, which is 360, and I divide that by 2, I get 180, which is going to make up the three angles of the triangle. Okay, so if I wanted to find the measure of each angle and arc, here we've got angle B is 55. So if I'm going out to angle arc AC, we're going to multiply that by 2. So that's 110 degrees. All right, so, or if we wanted to set it up over here, measure of arc AC is equal to 55 times 2, which is 110 degrees. All right, we've got, let's see here, we've got a diameter here making two semicircles. So this one is 180 degrees. This other semicircle is being broken up into two parts. First part is 110, which means that the other part is going to be 70 degrees. So now that we've got that inscribed angle, we can work, now that we've got that intercepted arc, this 70, we can work backwards to find this angle A. All right, so angle A, or the measure of angle A, I guess I should say, is 70 divided by 2, arc divided by 2. So the measure of angle A is 35 degrees. Now, to find angle C, we could do a couple things. We could say 180 minus 55 minus 35, which is going to make angle C a 90-degree angle. Or if we extended these chords of angle C out, this inscribed angle, angle C, we'll see that it captures the semicircle, and 180 divided by 2 is 90. All right, so we've got all the angles there of the triangle and all the measures of the arc. What about in part B? Find the value of x. Well, there are a couple different ways to deal with this. Either we can deal with arcs or we can deal with angles. So if I deal with angles, I need to take this arc and divide it by 2 to get this inscribed angle here, which is going to be 4x. And then I could set up 4x plus 6x plus 8x equals 180. So I'll get 18x equals 180, or x is equal to 10. All right, so that's one way we could do it. The other way is to deal with the arcs. So if this angle here is 8x, if I extend these chords out, that means that this arc is going to be 16x. Similarly, if I extend the 6x angle out, this arc is going to be 12x. Got to double it. All right, so I got the three arcs now. I've got 12x plus 16x plus 8x equals, all three arcs got to be 360. So I'll get 36x equals 360, so x equals 10. Does not matter which way. Both are sound math ways to solve for x. All right, so that's a triangle. Again, nothing new, just kind of different diagrams that we haven't dealt with in the previous videos. And the last example is inscribed quadrilaterals. All right, so in an inscribed quadrilaterals, opposite angles in the quadrilateral are supplementary. Remember that word supplementary means they add up to 180 degrees. All right, now each angle of a quadrilateral is an inscribed angle, but notice that it captures two arcs here. It captures two arcs. And the four intercepted arcs will add up to 360 degrees because that's going to make up the whole circle. All right, so if I wanted to solve for x here, notice if I extend these chords out, it's going to capture two arcs, 58 and 106. So in total, it captures 164. So x is going to equal 164 divided by 2. The arc divided by 2. So that's going to give me x to be 82. So x is going to be 82 degrees. All right, next up, what we can solve for, we know that opposite angles need to be supplementary, all right, because x captures 2 arcs, and y, which is its opposite angle, captures the other 2 arcs. So in total, those 2 angles capture all 4 arcs, which are 360. So 360 divided by 2 is going to be 180. So we've got 82 plus y equals, 82 plus y is going to equal 180 since they're supplementary. So then I'm going to get y equals 98. Okay, so y equals 98. I'm going to erase these. I'm trying to not mess up our diagram too much. All right, so now how else could we solve this? Okay, well, there's a couple things we could do. We've got 93 and z. Those are opposite angles. So 93 plus z is going to be supplementary. So they're going to equal 180. So 180 minus 93, z will equal 87. And I believe we solved for everything there. All right, we could figure out the other arcs and say, all right, if I extend z, I'm going to capture 2 arcs. Z is 87. So that means 87 times 2. This whole thing is 174. Part of it's 58. So if I subtract 58, I'll get that this angle is 116. And then we know 3 of the 4 arcs. So 360 minus 116 minus 58 minus 106 is going to give us this missing arc of 80. And we can double check that. 80 plus 116. If I add these 2 arcs together and I cut that in half, I get angle y, which was 98. All right, so that's just kind of ways that you can work your way through these diagrams if you've got an inscribed triangle or quadrilateral. Just remember the big relationship is that angle equals arc divided by 2.